I'm going to do a couple of examples from the homework on relative standing, and the main idea here is the idea of a z-score. And the z-score has a formula, z equals x minus x bar over s, where x is a data value, x bar is the sample mean, and s is the standard deviation. And what a z-score is doing, it's measuring a data point in terms of units of standard deviations above or below the mean. So for an example, find the z-score for x equals 21.8 if x bar equals 23.5 and s equals 4.1. So I'm just going to plug into that formula. Z equals x minus x bar over s. Now I'm putting a parentheses here because I'm going to do that on the calculator. X is 21.8. X bar is 23.5 divided by s, which is 4.1. So on the calculator, parentheses, 21.8 minus 23.5, close the parentheses, divided by 4.1, and that comes out to negative 0.41. Z-scores are typically rounded to 2 decimal places, so I'm going to write that as negative 0.41, negative 0.41, and typically 2 places are used for z-scores. Now, z-scores can also be labeled as significantly high or significantly low. And remember, it was more than 2 standard deviations above was significantly high, more than 2 standard deviations below was significantly low. So for z-scores, if it's more than 2, then that's significantly high. And if it's less than negative 2, that's significantly low. So for example, in the previous example, I had x bar equals 23.5, 23.5, and s was equal to 4.1. Suppose I gave a data value x, which was equal to 32.6. So this 32.6. So the z-score for that guy would be x minus x bar, 32.6, minus 23.5 divided by 4.1. There's the parentheses for the calculator. So I'm going 32.6 minus 23.5 divided by 4.1. That comes out 2.22 if I round it off to 2 decimal places. So because that's greater than 2, 2.22 is more than 2. So the data point value 32.6, so 32.6 is significantly high with its z-score of greater than 2. Now, z-scores give us a way of measuring what data values are more extreme than others, whether they be extreme by being high or low. And they have an example like this in the homework. Here's an example. So suppose giraffes have a mean height of 16.4 feet with a standard deviation, these are in units of feet, standard deviation of 1.6 feet. So which giraffe has a more extreme height? Which is more extreme? a giraffe that is 18.7 or a giraffe that is 14.9 feet high? Well, we can do this by calculating the z-scores and see which one is farther away from the mean. So for this guy, z would be 18.7 minus 16.4 divided by 1.6. There's the calculator parentheses. 18.7 minus 16.4 divided by 1.6. That's about 1.44 rounded off to 2 decimal places. So this guy is 1.44 standard deviations above the mean. This other guy, the z-score would be 14.9 minus 16.4 minus 16.4 divided by 1.6. So on the calculator, 14.9 minus 16.4 divided by 1.6. That's negative 0.94. Negative 0.94. So this guy is about 0.94 standard deviations below the mean. This guy is 1.44 standard deviations above the mean. So this guy, the 1.44, is farther away from the mean than the 14.9 guy. So the more extreme is the 18.7. 18.7 is more extreme. Actually, neither one of them are particularly extreme because they are both within 2 standard deviations of the mean. Neither is significantly high or low, but the 1.44 is the more extreme.